Hi everyone, this is going to be a video on how to do a couple of transformations. I'm going to use the remediation worksheet that I signed a couple of months ago, and if you want another copy you can download it from the class website. I'll put it on the same EOC Crunch Time tab on the class website. Alright, so I'm going to go over just a couple of things, not everything, and one of the things that I want to go over that I think is important is how to do reflections, how to do rotations, and how to do dilations that are not centered at the origin. All right, those are the couple of big concepts I want to go over here. So let's start off with some reflections. All right, so I'm going to start with number 2. I'm going to show you how to do a reflection across the line y equals x. Now, first thing I want to tell you is that some of you may have memorized the rule for y equals x. Now, the reflection over that line, the rule is this: x comma y becomes y comma x. The two coordinates switch places. It's a really easy one to understand. Now, I'm not going to show you the rule because we know how to apply the rule. You're going to switch the two coordinates. Okay. I'm going to show you the visual method, and this visual method is going to work with any line that has a slope of 1. So any line that is y equals 1x plus any y-intercept, which on your EPAT test, when we were doing those practice tests, they gave you some lines like y equals x plus 10, y equals x plus 4, all of these lines that you had to try and reflect over. That would be the same process that we're going to do right now for reflecting over the line y equals x, because the line y equals x is in the y equals mx plus b format. It just has a invisible 1 in front of the x, and then it's positive 0 as your y-intercept. So I'm going to go ahead and I'm going to draw the line. That's first step, is to visualize where your line is, the line that you're reflecting over. Now in this case, you put a point at 0, 0, and then you're going to go diagonally upwards as a slope of 1 over 1. All right, so I'm going to count diagonally 1, 2, 3, 4. All right, so all the way up, I'm going to plot these diagonal points. Same thing the other direction. Okay, now that I have all those points plotted, I'm going to connect it with a smooth curve, or rather not a curve, a straight line. Okay, that was a lot of effort, but I have that line plotted now. Now, if I want to reflect my points over this line, and my line is diagonal, I'm going to count diagonally. So watch as I start with T. I'm going to cut across 1, 2, 3 boxes. So I'm going to do the same thing on the other side. 1, 2, 3 boxes. And I'm going to end up right here. So my coordinate for T prime is going to be 1, 2, 3, 4, 5, negative 1. My coordinate for T before was at negative 1, positive 5. It was at negative 1, positive 5. That was your original point for T. So you can see the x and y values switched places. Let me do this again for U. So for U, I'm going to cut across the boxes. 1, 2, 3, 4, 5. And then again another 5. 1, 2, 3, 4, 5. And that's going to be point U prime. All right, next one with R. So with R, I'm going to cut across 1, 2, 3, 4, 5, 6, and a half. Same thing on the other side. Complete the half. 1, 2, 3, 4, 5, 6. And put my point. That's R prime. Now let's do S. So we have 1, 2, 3, 4, 5, and a half. Finish out the half. 1, 2, 3, 4, 5. Putting my point down for S prime. Now that changed the letter. Put that back. Okay, so S prime. And now I'm going to connect all 4 points to form my new image figure. Okay, so that's my image. Now reflecting across the y-axis, we know how to do that. We're just going to count to the left right, towards our y-axis. All of our points we're going to count on the left and the same amount on the other side. So I'm not even going to go over that. We know what that should eventually look like. It should probably look something like this, and I'm just eyeballing it. Okay, that would be your final image because we're going to do a composition of transformations. We're going to build one transformation onto the next, onto the next, onto the next. Okay, so let's take a look at another type of transformation. All right, let's take a look at number 3. If you remember, we have some tricks for doing rotations. We actually turn the paper and pretend we're looking at a brand new graph and write down the coordinates. Now, I'm not going to work out all of these rotations, but let's do a couple. So the first one says to rotate this shape 180 degrees clockwise. So that's basically like rotating the shape upside down. Doesn't matter if you go clockwise or counter. So I'm going to slide over here. I have the same exact graph, and I'm going to rotate it. All right, so I'm going to rotate it clockwise 90. It's going to look like that. And then another 90, so now I'm upside down, I'm 180. Now, if I read the coordinates the way they're drawn out now, I have x at -1, -1. I have w at 1, 2, 3, 4, 5, -5. Because I'm going to the left 5, down 1, so -1, and then v is at -2, and then I'm going down 1, 2, 3, 4, 5, 6, so -6. Okay, so on my original graph, I would take this, I would turn my paper all the way back, and now back on the original front-facing graph, I would plot my points that I wrote down. So -1, -1, would be x prime. Then we have -5, 1, 2, 3, 4, 5, down 1. This would be w prime. And then v prime would be at -2, down 1, 2, 3, 4, 5, 6. So right here. So this would be my 3 points for my graph. And this would be my image. Okay, so if you notice in our diagram here, it's appearing in the same exact space or place that the triangle that we just drew on our original graph is appearing. So it's kind of previewing for you where it should end up. All right, let's do one more. Let's do a rotation of this red triangle. Let's rotate it 90 degrees counterclockwise. Okay, so it's 90 degrees counter, which means you're going against the hands of the clock. So this figure here that I have in red, it should rotate 90 degrees counter. So it should probably end up here somewhere. Okay, so that's what I'm going to imagine is going to happen. So let me clean this up and we'll come back in just 1 second and we're going to rotate this one more time. Okay, so now I've copied this diagram because what I want to do is I want to turn the paper 90 degrees counterclockwise. So I'm going to take this image and I'm going to rotate it counterclockwise 90 degrees. So that's going to be one 90-degree rotation. Now let me undo that. That was incorrect. Okay, so that would be my one 90-degree rotation. So this is what your paper should look like. And now let's write down the coordinates again. So our coordinates for x are now at 1, -1. And remember, I'm looking at the coordinates here on my red diagram because that's one that I want to be rotating. Okay, next, I'm looking at v, which is at 1, 2, 3, 4, 5, 6. Down 2, so 6, -2. And then w is at +1, down 1, 2, 3, 4, 5. So 1, -5. All right, so these are my new coordinates. So I'm going to plot that on my graph for the one that I'm doing all my work on. So for you, you're going to turn your paper back so that it's facing the normal direction, and you're going to plot these 3 points. So it's going to be at 1, -1. That's x double prime now. V is at 6, -2, so 1, 2, 3, 4, 5, 6, -2. And then we have W prime, which is at 1, -5. And so here would be our new and final image because I'm not going to work out that last one. Okay, so that's how you would do some rotations and some reflections. Now, watch the next video for how we're going to do some dilations on the origin, or rather centered at the origin, and then off of the origin.